Welcome friends, so let's take a look at this interesting limit. The limit as x approaches 0 from the right side. Remember on this channel I usually post more advanced math videos, and then it's going to be here. Sine of x raised to the 1 divided by ln of the square root of x. A nice little limit. A variable base sine x and a variable exponent 1 over ln the root of x. Is there a particular form that applies here? Well, when x goes to 0 from the right side, then sine x goes to 0. Okay, and then when x goes to 0, then 1 over ln of the square root of x. So when x goes to 0 from the right side, the root of x goes to 0, and ln goes towards negative infinity. Anyway, you have 1 over infinity of some form, so you end up with 0. You have, in other words, 0 raised to the 0. We've got that kind of form going on here. So we need to recognize that. So now we apply the basic trick where we can rewrite this as the limit as x approaches 0 on the right side, and then just rewrite that as e raised to the ln of sine of x. And then here that 1 over ln the root of x, you can just place that under here like this. Now here, again, by basic property, you can slip the limit into the exponents. You're going to have e raised to the limit as x approaches 0 from the right side. And then it's going to be here ln of sine of x, and this whole thing here will be divided by ln the root of x this way. Now what happens in this particular case? Let's think about this. When x goes to 0 from the right side, sine x goes to 0, that means ln of sine x, that goes towards negative infinity, essentially. You can check it if you like, you'll see. And then the bottom, when x goes to 0, root of x goes to 0, which means ln of the root of x, that goes to negative infinity. See? The way to check that is you just graph the top and the bottom independently, and the graphs will confirm what I've just said. Now that you've done that, you have infinity over infinity, we can slope it out, right? We're going to have e raised to the limit as x approaches 0 from the right side. And then this is going to be 1 over sine x. And then you're going to have to multiply. Again, this is going to get a bit huge here. Now, let me write it this way then. 1 over sine x, and then multiply by the derivative to get a cosine x, right? And now in the bottom, ln of the root of x. You have to form that derivative. So it's going to be 1 over the root of x and multiply by the derivative of the root of x, but that's just 1 over 2 square root x this way. That's an elementary derivative. Let's clean this up. E raised to the limit as x approaches 0 from the right side. And in the top, so we're going to say 1 over sine x, and then times that cosine x. We have to rearrange this expression the right way. So we have the root of x times the root of x. That's going to give you 1 over just x. The roots cancel, and there's an extra 1 over 2 in this position this way. And then here we're going to have e raised to the limit as x approaches 0 from the right side. And now this 1/2 times 1 over x is really like 1 over 2x. So by basic properties of fractions is 1 over sine x right here, and then multiplied by 2x times the cosine x. Continue here is going to be e raised to the limit as x approaches 0 again from the right side, and then regroup this. So you can pull the 2 out as a constant, and then group it as x over sine x times cosine x. Now that's useful because now we have e raised to the second. The limit as x approaches 0 of x over sine x, that's known to be 1. The other value there, cosine x, you can just do through direct substitution. You just have cosine of 0, which is 1. Therefore, we have left e to the second, and this is the value of the limit. So if you like advanced math videos at this level and similar levels, please be sure to subscribe. We'll see you in another video.